All right, so yeah, let's do a really quick review on Euclid's algorithm for finding greatest common factors, because you need that for the fraction class. And ideally, you won't get too bogged down in the details of this. So let's do an example. So let's just do 150 and 35. Right, so if this was a fraction, you'd want to find the GCF and then divide both of those by the GCF. So Euclid's algorithm does the following. It says 150 equals something times 35 plus something. So how many times can we put 35 into 150? Well, I think it goes in about 4 times with 10 left over. Okay. We ignore the 4. We take the 35 and we take that remainder. And we say 35 equals something times 10 plus something left over. So this goes in 3 times with 5 left over. Take that 10 and take the remainder and repeat. So now 10 is 2 times 5 with nothing left over. At that point, this last remainder, that's the greatest common factor. So we divide both of these by 5. And there's your reduced fraction. These things always explode on me. See if it explodes. It's just water, so it's not like horrible.
Not today.
On my watch. All right, so how do you do this? It's a while loop, depending on how you want to construct it. It's some kind of a loop. You need to keep 2 numbers, right? So you've got A and B. Maybe you could call them something better than that. And then remainder equals just A modulo B. And now you basically want to find the greatest common factor of that remainder and B, right? And you can do it recursively, but you can also just loop back up here. So set A equal to B and B equal to the remainder, and go back and try it again. And do this until the remainder is equal to 0. And once the remainder is 0, the GCF is, well, it's the last remainder, which is B, right? And the first time that you do this, if you have something like 150 and 50, so your remainder will equal 0 the first time through, and you say, okay, so B is the greatest common factor. Well, that's perfectly correct. And if you do these in the opposite order, if you start with 50 and 150, then the remainder of A divided by B is going to be 50. And so now you'll set A equal to B and B equal to the remainder. And you find the remainder when you divide these, and it's 0, and so your GCF is the last value of B, and that still works. The only time you kind of get into trouble here, well, there's a few cases. One is if you have negatives. Okay, and if you have negatives, don't try to do this with negative numbers, because modulos are weird with negatives. Just work on the positive values. But when you're done, take your original numerator and denominator. You can still divide by the GCF. The GCF is positive. It'll preserve the signs of these when you divide. Right, so feed the GCF the absolute value of your numerator and denominator, but then divide your original numerator and denominator by that GCF. The other way you can get into trouble is if you have one of your numbers equal to 0. Because when you try to take the remainder divided by 0, you'll get an exception. But if you have a fraction with a 0 in the denominator, you should be recognizing in your code that that's an invalid number. You shouldn't be trying to do anything to it. Right? Your simplification might just be change the numerator to +1, or set a flag saying this is undefined or something, but there's no need to, and there's no way to find a GCF. What if the numerator is 0? What if you got a fraction like 0 over 10? So the remainder when you divide 0 by 10 is 0. Your remainder is 0. Your GCF is b. And if you divide a and b by that, it'll reduce your fraction to 0 over 1, which is the lowest common form for 0 in some sense. So it kind of does everything that you wanted to do sort of for free. Yeah.
So when we were going through talking about what you think we should like program first,
Mm-hmm.
do that. In my mind, what makes sense would be to like do the input and get the fraction, and then do the simplification next, and then every time you get in a fraction, you just simplify it, and then you have like a baseline.
Yes. Yes. The reason I said you don't have to worry about this up front, though, is that if you're not worried about putting things in simplest forms, then you never need to put them in simplest forms, right? So you can construct a fraction that's, 15 over 3, and you can multiply that by 2 and get 30 over 3, and still feel like your multiply routine works perfectly fine, right? And this, it's a simple algorithm, but people, you can get bogged down on this, right? And if you spend 2 days getting your Euclids algorithm to work, it's just kind of demoralizing sometimes that you haven't even gotten to like dealing with fractions yet. So for that reason, I said, you can kind of leave this for a quiet time when you feel like biting into it. It doesn't usually take people 2 days, but if you start down a really weird path and you're kind of watching TV while you do it or something, it can kind of grow into something worse than it needs to be. You get a question coming?
No, I don't know if it would work, but could you do this a different way if you wanted to not use Euclids?
Like what?
I don't know, I was thinking just try to divide everything by either 2 or 3 until they were both, until that didn't work.
This is just one way to find GCFs, okay? There's definitely other ways. But this is probably your best bet. But you can do something like write everything as a product of primes, and then find what the common factors are. And the only common factor is 5, and it only goes in once, so that's your GCF. But that requires you to write your numbers as primes and keep track of the powers and things like that. It's definitely going to be more work. Or you could hack into NSA and run their Euclids algorithm.
It's a lot easier.
Yeah. Yeah, there's probably other ways to do it too. You could try every number, right, from 1 up to the smallest number and see if it divides the largest. And whatever the largest number is, that's your GCF. That's the most direct way. But if your numbers are in the millions, it takes a lot of work. And Euclids is a pretty direct path. So other questions? Look like you want to ask something. Okay. All right. So I went through your lab 1 lab reports and I graded those, and those all looked great. Looks like everybody that turned one in was able to get on the air. If you're working from a Mac, the screen command seems to have some quirks. In particular, if you run the top command, it doesn't seem to exit when you hit a Q. Normally, if you just say top, right, it shows you the screen. And this is one of the few commands Control-C won't get you out of, along with more. But just hitting a lowercase q should take you out of this. But on screen, that doesn't seem to happen. And I don't know if there's a flow control issue where it's like sending too much output and it stops listening to input or something. But Minicom seems to be a little better behaved on Mac than screen. If you run Minicom, it says to use the meta key to go into the setup, like meta A followed by a Z. So apparently the default meta key is an escape key. It's not the clover leaf, it's not control, it's not alt. So escape A seems to bring you into the setup menu, or escape AZ. So if you want to try that, let me know and I can help you with it. The other option is if you do minicom-s, that brings you right into a setup option. And one of the options after you've set up all your things, you can say save this as the default. And after that, if you just say minicom, it should automatically remember your settings. So there's different ways to do that. Yeah.
For Windows, if PuTTY doesn't work, is there another alternative you can use?
If PuTTY's not working for you on Windows, what you want to do is go look for a CP2102 driver. And normally Windows 10 this seems to work, but some versions of Windows 10 it doesn't seem to. So CP2102 Windows driver. And don't do the VCP driver. Just look for straight 2102 or 210X drivers for Windows Update. Download this and run it, and it should install the driver for you. And then plug your device back into a USB port, and it should show up under Device Manager, either under USB or under ports, and it should give you a COM port. And then PuTTY should work. All right, so the lab reports all looked great. Looks like people got everything to work the way it was supposed to, and so on. Let me make a general comment on lab reports. This is for going forward for labs 2 on. A couple of things. One, and this works for everything you do at Clark and probably the rest of your life, stick to full names, okay? Don't just use your first name or an initial or something like that. This is for yourself, for your lab partners, for anything you're doing. Get in the habit of using full names, okay? There is redundancy. So if you're listing your partners, first name, last name is a good idea. The other thing, I would like your lab reports to read as a standalone document. Okay, so when we do homework assignments, it says, run the df command and see how much space you have. And so you might write, step 1, 3.2 gigabytes. And then it says to go into the options and try to expand the file system and reboot. And so you might say to 15.7 gigabytes. And then it might say, look at some other options, and 3, enable camera, and so on, okay? This is not a lab report. This is like a homework answer sheet. It's great for turning in on homework, but as a lab report, if you were to publish this, and someone goes to the library and pulls this off the shelf and starts reading it, they don't know what they're seeing. And they don't know what you've done, okay? So when you're doing a lab report, think of this. Somebody else wants to be able to read my report and try to reproduce my results. Okay, now this isn't science in the sense of looking at something under a microscope, but you can use that same mindset, right? If somebody else has a Raspberry Pi and they want to know, if I expand the file system, do I get the same amount of disk space that you did? They've got to know what you did, okay? So lab 1 was just kind of a warm-up. It was a hello world. So it's just kind of like do these things and report on that. But starting with lab 2, you're going to be writing code, you're going to be building a simple circuit, and you're going to be running this to see if it works in certain ways. So put in a few sentences and just sort of say what you're doing, okay? Don't just say, we built the circuit and the LED blinked. Draw me a little picture of the circuit, okay? It's going to be like 3 pieces to it, mostly wire, so it's not like, a 250 2-bit adder or something.
Oh, no.
No, I didn't say it. So think about it, is this a standalone report? That was my only real comment on that. So keep that in mind for lab 2 and forward. All right, let's look at our rectangle class. So let me tell you what we're doing today. I want to introduce a keyword, which is the keyword this, and it's going to be a pretty useful concept to have available. So I want to do this by way of looking at our rectangle 2 class. This is kind of a side note. And then mainly what I want to do is I want to give you a more interesting example than this rectangle example that we used last week. I want to use an example where part of what we're doing is actually creating a new object within a method of this class. Okay, similar to what we're doing in, say, the add or subtract method in the fraction class. And I want to develop that and talk about the details of it. And that should help if you're sort of stuck on how do I add 2 fractions and return a new fraction, right? This should help. So, so we'll get to that, and then we'll start digging deeper into the language and moving towards talking about exceptions and arrays and doing input, since we already know how to do some output. So, smattering of stuff. But let me start with this one kind of side topic, which is this notion of the keyword this. So here's our rectangle class. Yes? Oh, I thought I did, man. These buttons are weird, and they don't like being rushed, so you gotta turn it all the way off and then hit the other button. Okay, how's that? Yeah. Someone needs to put a delay loop in there. Yeah, put a 555 in. Decrease the capacitor. All right. Yeah, additional. All right, so here's our rectangle class from last week. And remember, it's got these 2 variables called height and width. And that stores the height and width of the rectangle that we're talking about. So when we construct a rectangle, we give it a height and a width, and those values get stored in these 2 variables. Okay. Now, the constructor, which got moved way down to the bottom, looks like this. And we got fancy, we called the set height and the set width method, but let me get rid of that. And let me go back to what we originally had, which was basically we say set the height equal to h and the width equal to w, where h is the first argument and w is the second argument. Okay, and everybody understands why this works, right? When you construct a rectangle, we say new rectangle 5, 3, h is equal to 5. The first line sets height equal to 5. The second line sets width equal to 3. And now every time we refer to this rectangle, that height and width pair variables store the 5 and the 3 for us. But h and w are not the best choices for variable names, right? H could be anything. W could be anything. If we want to stick to good programming habits, this might make more sense, right? We should call our argument something like height and width. But if we do that, we're led to the following silly pair of statements, right? Which doesn't really make sense. I mean, it kind of does. We know what we're trying to do. We're trying to set the class variable itself, the height of the object, equal to this first argument, and the width equal to the second argument. But the reason this doesn't work is because in a function and in a method in Java, arguments are local variables, right? We can do anything we want to height. When we say height, we're referring to the argument here. So here, we're correctly referring to the argument that was passed to the constructor. But over here, we're still referring to that same argument, and we're setting the argument equal to itself, which is a no-op. What we really want to do is set this height equal to what that first argument was, and set this width equal to what the second argument was. And we can do that by putting in this keyword this. So when we say this dot height, this highlighted stuff here is referring to the variable named height that was declared in the beginning of the class. Whereas over here, when we just say height, that's referring to this first argument on the constructor.
So the meaning of this dot, like something else is name at the beginning of the code or the class?
In effect, yes, but I can be more accurate than what I was. Let me tell you exactly what this means. So let's say we have rectangle R1, R2. And we construct those in some way. And then at some point, let's say we call a piece of code R1.area. Okay, so we start executing this code inside this area method. If inside that code the word this appears, it means R1. But if at some point we call R2, say the area method, and we encounter the word this, now it refers to R2. It's a way for an object to basically identify itself. Within an object, the word this means that object itself. Okay, it's kind of like I. It's the ego operator. So if I want to know what R1's height is, I can say this dot height, and that means R1 dot height. But if I say R1 dot height, it's always R1 dot height. If I say this dot height, but I'm inside R2, it means R2 dot height. Does that make sense?
So we can use only like this dot something else.
It's this dot something that you could say R2 dot.
So only in the beginning. And
It could be anywhere.
But it's proper to a class or a method, right?
Say again?
It is proper to a class or a method. You can only use it for that method or that class.
It refers to the object,
Okay.
right?
Oh.
So this gets subtle, right? So this whole thing is a class named rectangle. But somewhere inside here, if I say this dot area, it means the area method of whatever object I'm using to, call the toString method in this case. If I say this dot width, it refers to the width double associated with whatever object I use to call the toString method. Okay, so you can think of this as really kind of meaning this object itself, right? It's one of these things that's like pretty easy to use once you know how to use it, but it's really hard to describe. Okay, partially because it's an ego thing, right? It's self-referential. But in practice, the way we use this is really just, this is the most common use for it, right? We're trying to get outside the local scope of this method and say, I don't mean the height variable in the argument list, I mean the height variable in the class description, right? So it's the height of the actual object that we used when we called the constructor. You don't need this, right? We can call our arguments h and w and then just say height equals h, width equals w. That works great. But you'll see the keyword this in a lot of code, and it's a way to avoid having to pick a different variable name just so that height refers to the outside thing.
so actually like we do need to use like use that something only is only easily to like discern like the variable or something like that.
Yeah, it's really just to avoid an ambiguity,
Okay.
right? Because since I have a local variable named height, if I just say height, it means the local variable. Did you have your hand up, Henry?
No.
Okay. All right, so that's a convenience that we can use, and we'll start using it in class. But if you're unsure what it means at some point down the road, you can always just keep asking, right? No ODPs today. I might do one tomorrow, depending on how far we get. I'll do one either tomorrow or Wednesday. All right, so I want to spend the bulk of the time, first half at least, talking about going through an example of building a more interesting class than the rectangle class. Because rectangle, we make a rectangle and we just kind of like measure its height and width and area and perimeter. But let's actually make a class where we actually return new objects. And let's see how we can do that. So I want to make a vector class. So how many people here have done linear algebra? Oh, good. You'll like this then. So if you haven't, don't worry about it. We're not going to get bogged down on details. But nominally, we're going to think of a vector as, picture a three-dimensional space. And a vector is just a line starting at the origin and ending somewhere. So it can go anywhere. It can have different lengths. It can have different directions. Okay, but it's always sort of anchored at the origin, and it goes out to some point. Okay, everything that we need to know about a vector in three-dimensional space can be captured with three pieces of information, right? All we have to know is where that vector ends, the x, y, and z coordinates of the endpoint. So to store a vector as a new type of object in Java, we need to be able to get a hold of its x, y, and z positions. So let's make them doubles. And we'll just call them x, y, z. All right, so let's write some code. So we'll call our class vector, so it's in a file called vector.java. So there's my into my documentation, a Java class for working with 3D vectors. And the main variables we're going to store are x, y, and z, the coordinates of the endpoint. Okay, we'll make one constructor. So when you want to create a vector, you have to tell it what the x, y, and z coordinates of the endpoint should be. So our constructor is just called vector. And it takes 3 double arguments, which we'll also call x, y, z. And we'll store those in our instance variables x, y, z by using the this keyword. And that's really all we need to construct. All right, well, we want to be able to print out vectors. And we're not going to write a print method in here, but we're going to write something that can be used with print line to take a vector and turn it into a string. So what's that called?
toString.
That's toString. So let's make a method to allow vectors to be converted to strings. It's always got to be public. It's got to be called toString. It takes no arguments. Barring errors in my quotation marks, which I'm sure I have some. Maybe not. What I'm going to return is a string consisting of a left parentheses, followed by x, followed by a comma, followed by y, followed by a comma, and then z, and then a right parenthesis. So this will print out a vector as, you know, an order triple, the way you do in math class. And for now, that's the end of our class. So let's make a main method. So I'll make some vectors A, B, and C. And we'll make a vector 1, 1, 1. And we'll make a vector 2, 3, 4. I don't know why. All right, we're just going to print out A and B. So we're just kind of warming up here. We're not actually doing any construction on the fly. So we got some vectors. We'll construct A and B as being those vectors, and then we'll print them out and just make sure everything is still working. So we'll compile. Typo somewhere.
Class capitalized?
Yes, it is. It's even worse.
Oh, vector is lowercase.
O and B.
Down to 6 errors. Public toString, return type required. Oh, yes. So this has to be a string. Everybody is already defined. Wow, we're having a good time here. Oh, I used A for my arguments. Okay. Two errors. There's what I expected. Parenthesis plus x plus comma plus y plus comma plus z plus parenthesis. And there we go. Okay, so how many times did we try compiling? I don't know, 7 maybe? And if you take a very sort of mindful approach to writing your code will compile first time, right? Well, that's not fun. That takes a lot of work, right? I'm talking, I'm drinking my bubbly water, and I'm writing code, and I'm making silly mistakes, right? But I'm okay with that because it takes me almost no time to compile and to edit. Okay. Now, how am I doing this up here? I don't know if you've noticed this or not, but so I'm on a Linux system, right? I'm working in a terminal window. Most terminal windows understand tabs. So I have 2 terminal windows sitting up here, and I can click on these tabs and switch between one and the other. Okay, and it's just like a tabbed browser. It's nothing mind-numbing. But you can also set up a keyboard shortcut to switch from one tab to another. And I just have a shift arrow key set up, so I can just hit a shift arrow key and go back and forth. Okay? And why do I do that? What's wrong with quitting out of here and then saying Java C? Well, nothing, but it takes a little longer. And every time I have an error, I've got to come back and I've got to re-edit. Right? So if I use one window for doing my compiling and running and another window for my editing, it actually saves me a lot of time. The other thing is, here I've got vector.main, but inside VI you can say VI main.java. And if I know that I can hit a Control-6 to go back and forth between these, I don't have to keep exiting and saying VI this, VI that. Now, how much is it worth to learn that Control-6 switches between two windows? I don't know. Put it on a sticky note, right? If you think it's useful. And you'll have to refer to your sticky note the first few times, but eventually, if you use this a lot, and I use it a lot, right, you'll remember it. And it speeds up your whole development cycle, and it can speed it up dramatically. And more than that, it saves you from coming out of your head, right? I don't have to think when I want to try compiling this, right? I just come over here, and I just go back to my last Java C, and it compiles again. And that's the real goal of getting comfortable and building a toolkit in something like a Unix environment or Cygwin or whatever your environment of choice is, right? Is to try to be efficient at it so that it doesn't distract you. Another thing I can do is make myself some aliases. And now every time I want to compile, I just say C. You gotta avoid typos though. So now when I want to compile, I just say C, and when I want to run, I just say R. So just things to keep in mind. All right, well, I went ahead and ran the code anyway, and it showed us our two vectors, 1, 1, 1, and 2, 3, 4, and that is exactly what we wanted. So our toString method looks good. Because I can construct a vector and I can print a vector, now I can start developing code that uses these vectors, and I can check my results by just printing out the value of the vectors, right? And I have confidence that'll do the right thing because I tested it twice. So it must always work, right? Okay, so let's make an add method. And this is similar to what you have to do with your fractions. Your fractions, you have a fraction, an object that's an instance of a fraction class. And you're going to use, say, the add method in that fraction. You're going to pass it a second fraction, and you want it to return a third fraction. Okay, we're going to do the same thing with vectors. So we're going to have something like vector A comma B. And we'll initialize A, and we'll initialize B. And now we want to do the following. We want to say A dot add, and we want to give that an argument of something like B, and we want that to return a vector which we could say set C equal to. So we want this to work. C equals A dot add parentheses B. Okay, so here's the crash course linear algebra. How do we add two vectors? So x1, y1, z1 plus x2, y2, z2 should give us x1 plus x2, y1 plus y2, z1 plus z2. That's the end of our linear algebra lesson. If you want to add two vectors, just add each pair of components. Okay?
Is this going to be on the test?
This will be the whole exam.
Nice.
I'll just give you 100 vectors and say add these.
Add them up. Make a program that adds them all up.
Suck this
Yeah.
up on the attic.
Nice.
Well, you fellas would be easy.
All right, so the code we want to actually use, the process we want to do to add these vectors is not the challenge here. Okay, just like with fractions, you want to multiply two fractions, multiply the numerators, multiply the denominators, you're done. The tricky part is the mechanics of Java and objects and classes and sort of making this happen in a reasonable way and producing a new vector out of thin air that we can return and then assign to C. Okay, so how would this work? We know that we need to take the x component of A and add it to the x component of B. And that's going to be the x component of C. So let's just write a line of code or two to do that. So Here's a method for adding two vectors. All right, here's some documentation. So we're going to write a method called add. What's its return type going to be? It's got to be vector. It takes one argument, and what's the type of the argument? That's also a vector.
And the opposite, I'm like,
Vecrot. Don't get vecrot. Okay, so vector add, vector argument. And yeah, we should say public.
oh, okay.
It'll default to public in some sense, but yeah, be better than I am. Use public everywhere that you want it to be public. All right, so what do we want to do? We want to add the x component of the argument, right? That's the second number, to the x component of the first number. Well, what is the first number?
Just nothing.
I heard it over, yeah, this dot x, right? This is the first number, right? So we want to take this dot x plus argument dot x. That's the x component of the new number, of the sum. So let's call that result x. And we'll make that a double. All right, if that line makes sense to you, then you're past the hurdle. Okay, this is probably where it's most confusing. And we didn't need the keyword this. We could have just said x plus argument dot x, but that's even a little more confusing.
I think we're hung up on like the looking at the scope of the entire class as
Mhm.
opposed to just that, not that method, not function, but like it's being used, but it like yeah, that's
Yeah,
confusing.
yeah, it is a little weird, right? So on this line right here, if I just say x, it's got no choice but to refer to this x up here. That's the only x that's declared that can be seen from here, right? So I don't really need to say this dot x, but it's referring to this variable up here. So what does that mean? Well, if I'm saying a and I'm calling a method from a, this dot x means a dot x, right? And argument dot x means b dot x, because b was the argument and I called my variable's argument. All right, so this will take the two x coordinates and add them together, and I'm just storing it in a temporary variable called result x. And I'll do that for y and z also. Yes?
So why do you have vector argument in the argument, like what that method takes in?
So my add method needs a parameter passed to it,
Yeah.
right? And it's a type vector, and I just decided to call it argument. I could have called it anything I wanted.
Okay, that's the type.
Yeah.
Yeah. Just decided to.
We're going
forget,
back to
like,
C.
Okay.
Months of C info.
Yeah, yeah. All right, so now we know what the x, y, z coordinates of our new vector should be, and that's the vector we want to return. We have to construct that so that we can return it. And how do we construct that? Just call the constructor. And we could say something like vector result equals new vector.
Could you just return the new vectors?
We could. Or we can do that. Or we could do the whole thing in a single line.
Oh my god.
Right? Take the x, y, and z coordinates and add them together and pass that to a constructor and take the return from the constructor and return that as a function value.
Which would be most preferred by people, you think?
Probably the one-liner. It depends on the complexity, right? Since we're really kind of doing the same thing 3 times. I mean, you would almost never see this pair together,
Yeah.
right? It doesn't do any harm because we still need to store this thing somewhere so we can return it. All we're doing is kind of wasting a piece of the namespace, right? Calling it a vector and getting rid of it. It's not really doing any harm, but it's pretty redundant to do that. So you would probably at least see those two combined, but if it's pretty easy to calculate result x, y, and z, it wouldn't be unusual to just put them right in the constructor.
Is it still not necessary to put what you're returning in parentheses?
I don't think it's necessary, but I've never done that.
I guess it comes down to like if you're just returning a variable or one thing, then it's okay to not have it. But if you're returning something a little more complex,
I don't think it requires them.
you're not required, but just like visually, it makes more sense.
Yeah, I mean, some would say that just having a space there makes it as clear, but I don't know.
This kid.
Yeah. Yeah, I don't think it hurts to have parentheses, but there's right. It's not like a function call where you might be doing something with it afterwards, and so you want to know which part of this expression goes with the return or which part goes with the thing you're multiplying it by. Right? It's pretty unambiguous, but I always put parentheses. There is a go-to statement in Java, by the way,
There you go.
but it's not implemented. But go-to is a reserved word, so you can't call a variable go-to.
Isn't it
But-
in C also?
No, in C it's actually part of the language. You can say go to a label, and it actually works, as it should. But in Java, it's not implemented. It was in one of the very early versions of the Java virtual machine, apparently, but then it got removed.
Well, I know you want to use go to anyway.
I got no problem with go to, but one can make a mess of their code very easily if you have go-tos in it. That's the basic reason. Because some may abuse, none shall be allowed, or something like that. So I don't know if we've had this talk before or not, but like back in the 70s, right, code didn't have things like if then else's, and it didn't have while loops and things like that. So everything was done with go-tos. If you wanted to do an else statement, you would say if something's true, then go to this, right? And then you'd list the else statements after that, and then you'd go past the statements you wanted to do if the if statement was true. Kind of like what you do in 270, right? Because we don't have loops and we don't have if then else's. It's all done with branches.
But you said there's no ifs.
There were ifs, but some languages didn't have an else statement.
Oh,
It was
okay.
just like if condition, then do this. And so if you wanted an else, you'd use a go-to to skip past stuff, right?
I've been pretty amazed at how Lily, you have to technically use else.
Yeah, yeah. I honestly don't remember if Fortran 4 supported else or not. But what would happen is you'd write your code and it would have more and more go-tos in it, and when people started maintaining code and modifying it, they'd say, okay, I want to do something extra between this line and this line. And so they would say go to extra stuff, and they do their extra stuff, and they did extra stuff. At the end of that, they'd say, go to, you know, wherever you were supposed to go next. And then someone would modify the extra stuff and say, okay, so
Oh
go
my
to
God.
over here. And you got what was called spaghetti code, right? Where you like pull on one strand and it like everything's connected to it. And maintaining that code and modifying it just got more and more expensive. And this is where you got things like, you know, 90% of the cost of code was spent in maintenance. So the shift towards structured programming, part of the idea was get rid of these go-tos. You don't need them, you can always do things with loops and conditionals, and it was supposed to make code easier to maintain, and so some languages just completely got rid of go-tos, right? And there are all kinds of books like go-tos considered harmful, and then there was a book, Go-To's Considered Harmful, which was supporting go-tos, and there's all kinds of, and there's some good XKCD comics on this, and so on. But, you know, the reality is, under the hood, you're always doing these branches, right? Your machine language usually doesn't have structured methods to it, right? It's just a bunch of branches, conditional or unconditional. So, but we don't maintain the code at that level usually, so it's okay. All right, so there's an add method for our vector class. I don't know if it will actually work or not, but let's try it.
Since you said no, you said the new vector inside of the class, you don't have to say new vector inside of main for C,
You don't want to. You could, but it would be
like malloc implies.
it would be like mallocing something that we didn't need to malloc. So if I say something like C equals new vector, right?
Yeah, you can see the
And then I immediately say
yeah.
C equals A dot add. That old vector is now just garbage, right? And it'll get reclaimed eventually by the JVM. So we don't need to say that.
Is it like the JVM kind of buffers us from screwing up too much?
Yes, yes, which is nice. All right, so this should take A and B and add them together, and it should give us the result. And let's see, we're doing 1, 1, 1 plus 2, 3, 4. It should give us 3, 4, 5, if my upper math is correct. So we'll compile that, and we'll run it, and there's our sum of our two vectors, 3, 4, 5. Woo. So that's really all the mechanics you need for PA1, right? There's the two double business, but that's easier than any of this. But basically converting to a string, and then there's an example of a method that takes the current object, adds another object, and then returns a third object. And your add, subtract, multiply, and divide will feel very much like that. All right, questions here. Let's do a 5-minute break, and then we'll start talking about more aspects of the language, and we'll talk about I/O. All right, so let's continue here. So, let me mention Eclipse here, because you may want to get Eclipse going before Wednesday. So if you just pop Eclipse download, and Eclipse IDE for Java developers, so this is what we want, okay? There's two aspects of Java. There's the runtime environment, which is called JRE, and there's the development kit, which is JDK. Wow. Yeah.
JK.
JK.
You really wanted to tell those jokes today.
All right, so JDK is what we want, okay? Runtime environment is you've got a piece of Java code and you want to execute it. It's really the virtual machine and a few other things. JDK is for developing in Java, so you got your compiler, you've got the debugger, you've got the thing for making archives and so on, bless you. So we want the JDK, and there's a few different editions. We really want SE, which is the standard edition. So if you have a choice, get SE. EE is the enterprise edition, that's even bigger, and it's got lots of things we don't need. And this whole thing is called an IDE, it's an integrated development environment. So you want Java, JDK, SE, IDE, A, B, C, D, E, F, G, whatever. But if you go to, if you put Eclipse download into your browser and come down here, Eclipse IDE for Java developers, it brings you to a page which conveniently says it was released 4 years ago, and it says a newer package is available here. I don't know why they don't just put it on this page. But click through to where it says here, and now you see a list of all these different options that are available. So Eclipse IDE for Java EE developers, that's the one that you want. Okay. Sorry, this one. Forget what I said. Don't do the EE version, just do this one, the second one. Okay, if it doesn't say which version, you can assume that's the standard edition. We're not a committer, we're a developer. This is the C version. I don't know, it's probably harmless,
Oh, okay.
but
You just don't like it very much.
I guess what's the difference between extended and standard?
so that's enterprise. So it's more kind of like what a business would use. So I think probably more security features and more control, but it may also put more restraints on what you do. It may be less of a Wild West kind of thing. So I've only ever messed with the SE version.
Programming of the Wild West.
Yeah. So that second one should get you there. And then you just download whichever version is right for you.
So I got mine downloaded, and it said that it was, I had 1.6 something, and it needs 1.8, so I went and downloaded 1.8, and then it's still giving me.
So this depends on the version of Java that you have also, okay? And so if you don't have Java already installed, go ahead and pop in Java download, and you can get it from java.com or oracle.com. It should be Oracle. And again, we want the standard edition development kit, okay, as opposed to the runtime environment. So go to the Oracle page, standard edition development kit, and click on that, and you have to accept the license agreement, and then just take the first one. So the second one is presumably a newer version, HU 16.2, but I would just take the first one. And if you're on Windows, 64-bit version, just click on this one. And then run that executable, and it should install Java on your system. And then if you go ahead and run Eclipse, it should find the JDK. And if not, come and talk to me or someone. But PA2, which we'll talk about on Wednesday, right, you'll want to do under Eclipse. So if you try to get this installed before then, we can talk about Eclipse issues in class on Wednesday.
Is that posted yet?
No. I gotta figure out what you're gonna do. All right. Let's talk about language. So you've probably already gotten the impression Java and C kind of look a lot alike in some ways. They're fundamentally different languages because Java is all about objects and C is not, right? But as far as the actual syntax of things, there's a lot of similarities. So we have variable types, int, float, double, char, same as we have in C. We also have a Boolean type, And Booleans are a genuine bona fide type of variable. And a Boolean variable can take exactly two values, true and false. So if you have a variable x that's declared to be a Boolean, you can say x equals true or x equals false. And it understands what you mean. And if you say x equals not x with an exclamation mark and it was false, it'll become true and vice versa. And you can do ands and ors and things like that with these Boolean values like you'd expect. C doesn't have a Boolean type. Well, original C doesn't have a Boolean type. It's really like a short int or a character. And it's basically a 0 or non-zero, right? So in C, 0 is false, non-zero is true. You cannot say if parentheses x, if x is an integer in Java, it'll say it's expecting a Boolean. You could say if parentheses x is not equal to 0, right? Or you could have a Boolean variable b, and you could say if parentheses b, and that'll work. You could say b equals parentheses x is not equal to 0, and it'll set b to the right Boolean value. Okay, but it's really a separate type of data. And there's a few others. There's a short integer and so on and so forth. These are probably the main ones that we'll deal with. And it needs to be pointed out that all of these start with a lowercase letter. And remember, we said classes generally start with an uppercase letter. When you make a fraction, you say fraction A, right? That's an uppercase F, because it's the name of a class. But there are a few of these variable types that begin with a lowercase letter, and these are primitive types. They're kind of shortcuts, because integers are actually part of a class called integer, with an uppercase I. But it would be a real pain if you wanted to say I equals 0, if you had to say the following: integer I equals new integer 0. People are going to flock from your language if you got to do that. So we have this shortcut int, which basically means an integer, but we can say something like integer I equals 0. And it'll effectively do something like this for us. And same with floats, doubles, characters, Boolean, shorts, and so on.
Why don't we have to say integer int if it's from integer?
Why don't we have to say what?
Integer int, you know, like if
You mean like integer x.
So int is a type of variable,
mm-hmm.
right? I is a variable of type int.
I just thought every time you use something from a class, you have.
It's
to
not really a part of the integer class. It's really it's another one of these asymmetries in the language.
Mm-hmm.
When you say int lowercase, you're saying, okay, I want to have an integer, but I don't want to write out uppercase integer, and I don't want to construct an integer,
mm-hmm.
and so on. And I don't plan to do things like I dot, hit some methods of that, and so on and so forth. So if you just say int lowercase some variable, the compiler will use that to say, okay, you actually want an integer named I, and you want to set its value equal to 0. It doesn't make sense, right? It doesn't follow from the other language elements, at least as far as I understand it. It's one of these things that's a convenience.
Just like a transcendental function, like sine or log, where it doesn't follow the rules of everything else.
Kind of, yeah. That's an interesting way to think of it.
So are there methods in the integer class? 'Cause I know
There are.
double has like manual.
Yes. So integer, the class, and again, I usually just say class name, class Java, and that'll bring me to the Oracle documentation, right? And it's got all of this stuff in it. So it has a few fields. So one is max value and one is min value, and that tells you what the largest and smallest integers are. And if I say something like, m equals integer dot, I forgot what the casing was, uppercase. max value. That's like saying, you know, C equals math.pi. It's a constant defined in this integer class. And that would set m equal to 2 to the 31st minus 1. And min value is the smallest, right, largest negative number. Size tells you how many bits you use for an integer, and type is, I don't want to talk about it. It goes into the primitive type of int.
So because you're running it on a JVM, it is dependent on the system you're running it on?
Correct.
Find some size for that.
Yes. Now there's a 64-bit and a 32-bit version of the JVM, and that can make differences. And if we Bugs Bunny to the future 500 years, right, and we check for max value, it might be something totally different. And if we hardwired our code to say, you know, use 2 to the 31st minus 1, our code might break. If we hardwire our code to use integer.max value, it might still work. Okay, so that's why they give you these fields. All right, we can construct by just passing an integer, which is a little redundant. But we can also construct by passing a string. So we can say integer x equals new integer parentheses and put something in quotes or something that we read from a file, and it should convert it, which I didn't actually realize till just now. So that's cool. And once we have an integer, we can call any of these methods. So what are these methods? Bit count returns the number of 1 bits in the representation of whatever value you pass to it. Why would you want to do that? Well, there's reasons. But we probably won't need to do that. But if you want to know how many 1s are in the binary representation of some number, you can use a bit count method. Integer.bitCount parentheses some integer. We can convert an integer to a byte by calling byte value. We can compare two integers by using the compare method. So we can say compare x comma y, and it'll tell us which number is bigger. How does it tell us that? Well, you can click through on any of these and see the details. So compare compares two values, and it returns a 0 or something negative or positive. And that feels like a cheat because it sounds like it's really just subtracting x from y and returning that. But we don't have to rely on that, right? So that's a way to compare. We can convert an integer to a double by calling double value. We can also just cast by putting in parentheses double, right? Return a hash code for this integer. Who the heck knows? So there's lots of things we can do, but some of the more useful ones, right? Here's a parseInt method, and we might have played with this when we looked at arguments. You can take a string and turn it into an integer by calling parseInt. We can turn it into an integer in some radix other than decimal. So we could pass it a 16 as a second argument, and it would convert from hex to an integer.
Do you think we could find we could simplify a fraction with one of these?
Probably, yeah. There's probably a do the fraction thing method. Reverse the bytes. So you have a 32-bit integer, it's stored with 4 bytes, right? There's a way to swap the order of those bytes. So if it's byte 0, 1, 2, 3, you can turn it into 3, 2, 1, 0. Why would we want to do that?
Encryption? Counting up and then counting back down again? I don't know.
Both possible reasons. Remember, on a computer, your memory is organized by bytes, basically, right? When you say, give me memory location 15, that's referring to a byte. When you want to store 4 bytes in memory, you've got to decide what order am I going to store those bytes in. If I'm storing an integer at location 15, do I start with the lowest byte or the highest byte? It's an arbitrary decision. But not all machines, not all systems use the same order. So if I'm networked to another machine that's storing integers in a different order from what I'm used to, every time I read an integer, I've got to reverse the order of the bytes to have it make sense on my system. So there's a method for doing that. How many people here know what the signum function is? Cool, we all agree. But if we want to compute it, we can call signum.
Significant number? Oh, sign.
Oh, it's a sign. Okay, signum. Signum. So, and we can convert to hex and binary and octal and all these other things. So all these things are available for us, right? And it's because integer is a class, right? Double is a class. Character is a class. So character with an uppercase C, we're going to find all kinds of things in there. Well, we can compare two characters. We can find the numeric value of a character that happens to represent a digit. We can see if a character is alphabetic, if it's defined, if it's a digit, and so on and so forth. And again, compare this to C, right? C, we have this is digit function, and if we have a character C, we can say is digit parentheses C. Here we would say C dot is digit paren, and it'll tell us if C is a digit or not, right? But the is digit code is part of the character class. So if we have a character, we've got certain pieces of code that go with that. And we don't have to sort of grab a piece of code here and a variable here and put them together, right? The code is in some sense contained inside that character. So that's the object mindset. And we can convert cases and convert to ASCII characters and all kinds of things. All right, so we have some primitive variable types, and then most of the things that we use with variables are going to be classes. So strings, for example, is probably the most common class that's not a primitive type, but that we'll use fairly frequently. But fractions and vectors and all these other things that we might create, those can be variable types also. All right, we touched on arrays. Let's touch on them some more. I got some vectors A, B, and C. Right, so I can just declare them vector A, B, C, but suppose I want 100 vectors. Right, we don't want to write vector A, B, C, D, X, Y, Z, A1, A2, A3, and so on, right? We want to use an array of some sort. So make an array of vectors. So I can say vector, I'm going to get this wrong. Vector bracket bracket my data. That makes my data an array of vectors. Let's start using camel case because it's fun to do. So camel case, you just uppercase like the first letter of words inside your variable name. Makes it easier to read. So my data is going to be an array of vectors. But if I try to do anything with this, right, say I try to print it out in a string, it's going to warn me that my data may not have been initialized. In fact, it hasn't been initialized. Because all I did was say my data is an array of vectors, but it's like saying integer star my data. We're declaring it to be an array of integers, but it's not pointing to anything yet. It hasn't been initialized. Okay, in C, if we tried to do this, we would get a seg fault when we tried to dereference my data. In Java, you don't even get compiled because it can look at it and say, hey, this thing doesn't have a value. I could cheat. I can give it a value. And you can assign null to most anything. So now it compiles just fine. And when I run it, it tells me my data is null. Now if I try to do too much with my data, I'll get an exception. But if you just try to print something that's null, it'll actually print it out as null. So that's not too bad. But here's what we want to do. We want to actually construct an array of 100 vectors, right? So I should be able to do this. Don't quote me on it till we try to compile it. Okay. Well, let's go ahead and run it and see what it says. So my data is, and it's just some gibberish because the toString method for an array of vectors is just showing me type of vector, type of object, and an internal address. But it's not null terminated, yeah. So here I'm actually giving values to each element of my vector. Well, let me try something. Yeah, let's do it. 42. All right. So let's try printing out the value of my data 42. Right after we say my data equals new vector. And there it's going to tell me that entry 42 is null. There's two things happening here. Up here, we're actually creating an array of 100 vectors, and we're saying my data is going to be equal to that array. But those vectors themselves have not been constructed yet. So this is like we have an array of vectors, right? When you say vector A is declared to be a vector, but it doesn't have a value yet, right? When we say new vector bracket 100, we've got 100 of those things like A. Each of those is a vector, but it hasn't been given a value yet. Okay, so my data 42 is actually null. So down here, what I'm doing is I'm setting each element in that array to actually be a constructed vector. And just for fun, I'm constructing each one to just have the same x, y, and z arguments as the index. So after I do this loop, if I print out my data 42, it should actually have elements 42, 42, 42. Right, so that's our constructed vector right there. So when you work with arrays of structures, you kind of have to do this two-step thing. You have to create a set of variables of that type. That's what that first new vector does. But then if you actually want to use those vectors, you have to either construct them, or you could set them equal to something or whatever. Yeah.
Is there a quick way to initialize them all to 0?
Yeah, there's some shortcuts you can use with curly brackets and stuff, but I don't know them off the top of my head, and I'd prefer you loop for now.
So is it automatically initializing them to null for you?
They're automatically null to begin with, right? Just like when I said vector A, if I tried to print out A, it would be equal to null, although it notices that it hasn't been initialized, so it won't compile. But it's kind of like when you have a pointer but you don't give it a value, it's a 0, that's basically null. So it's sort of the same thing.
If they're initialized to null at the start, why did it print out trash? Or something?
It didn't print out trash, so if I try to print just my data, remember when you try to concatenate an object to a string, it calls the toString method of that object, which in this case is an array. And so it gives you this kind of funny syntax. And we don't normally do that, right? But if we do, that's what toString is returning. And you don't need to use the new keyword here necessarily, okay? For example, if I wanted to do something different,
How does it know whether to use your toString or like the toString?
if you define a toString, it'll use yours. If you don't, it'll use the default one.
But didn't you?
Not for arrays of vectors.
okay.
Yeah, that's a little weird.
Yeah.
Let's make this really strange.
Our toString is gonna take the, you know how we want to make a vector specifically. So it's gonna take those three numbers and make it into what looks like a vector.
Let's make vectors of Fibonacci numbers for no particular reason. So I'm going to start off initializing two elements in this array, my data 0 and my data 1, to be vectors of just 1, 1, 1. And now I'm going to go into a loop from 2 to 30. I'm going to set element I to be the sum of the vector in elements I minus 1 and I minus 2. Which should give us something like Fibonacci numbers. And my reason for doing this is to show that I can initialize elements of this array without having to use the word new. Okay, because when I add these things together, I'm going to have a new vector. But this is not a language where we can actually do a plus sign on vectors and have it call our add method, right? So this is what we're after. But the way we write it is something like this. All right, so my data I minus 1 dot add my data I minus 2. I've never tried this before. I'm kind of excited. And then we'll just print out element 25.
You're saying they both should work?
They both should work. Well, no, the plus sign one won't work. But so that looks like the 25th Fibonacci number to me. I believe it.
It's a big number. So.
Yeah, it's big. Must be right.
In most circumstances, though, we would just use the new vector.
If you're really just trying to create a bunch of vectors that you're going to do something with later on, you'd probably use a new. But if you're constructing them from things that already exist,
If they're iterative, then
yeah, yeah. So what you want to do is avoid this. Right? If you're going to immediately set v equal to something, don't set it equal to a new vector first. Right? There's no need because you're changing the value of v right here. This is like when you say struct node star left equals malloc blah, and then you say left equals root arrow left. Right. That first assignment is doing stuff you don't need to do and in fact you don't want to do. You really just need to just say struct node star left and then set that equal to whatever you want it to be equal to. If you do this, you're creating a new struct node, you're pointing to it temporarily, and then you're changing your left to point somewhere else. Okay, same thing here. This would say, let's create a new vector, let's have v point to that, and now you're saying, let's have v refer to this other thing. And this poor vector is now orphaned. Nothing's referring to it. Did we mention garbage collection in Java? So we don't have memory leaks in Java because there's something called a garbage collector. And if you do something like this, if you create a vector and you have one thing referring to it, and then that one thing refers to something else, and nothing's referring to this vector anymore, eventually the garbage collector will notice that and it'll reclaim the memory. It'll basically get rid of this for you. So it does like a free for you. And in fact, you can't really do a free yourself as far as I know. You just sort of leave it up to the collector. Same thing if you create objects inside a method and then you return, and you don't return those objects or save them somewhere outside of that, they're basically gone, right? So the memory being used for them will eventually be reclaimed by the garbage collector. All right, let's talk about input. We know how to output things. We can say system.out.print or system.out.println, and we can cause things to appear on the display. Let's talk about the input side. And this can help you with debugging if you want to input numerators and denominators and then make fractions and operate on them and so on. There are about 10 zillion ways to do I/O in Java. Okay, there's entire chapters of large books dedicated to the I/O subsystem, all with really complex diagrams showing how things come from other things and so on and so forth. And as I've done throughout these courses so far, I'm going to try to give you a very narrow path through all of that and show you a few things you can do to do input, okay, and eventually output in Java. These are not the only ways to do I/O, but these are at least ways that I want you to know and be comfortable with and be able to use on tests, okay? And they will get you through most of what you need to do in your code. So the first thing we want to work with is what's called a scanner. Scanf, scanc, scanf, that kind of thing. Scanner. Scanners are used to ingest input. And we're going to rely on system.in, which is kind of like standard in C. And so normally system.in is referring to the stuff we type on our keyboard. But if we run a Java program and we redirect input or we pipe something into it, system.in refers to that redirected input or that piped output from another command. I call all my main classes main. I shouldn't do that, but that's okay. Yeah, I know.
Please forward all.
They said I wasn't creative.
All right, so S is what we're going to use to read from standard in. So we declared an object of type scanner. It's a class. We may as well take a look at it. So all these documents, they have some words in the top, and then a list of constructors, and then a list of methods. And then there's details on all of these. And there's a lot of methods available for just the scanner class, right? And there's several ways to construct it. We're going to construct it using this thing, construct from an input stream, and our input stream is going to be system.in. So all we have to do is say the following: s equals new scanner system.in.
Do we not need the whole public side coordinating thing?
Yeah, we do. I'd get all kinds of compilers if I...
I have the notes for my notes are correct.
So is Java just as forgiving with spaces as?
Yes, so white spaces are ignored except inside strings and stuff.
Can you also do main and empty input?
I don't think you can get away with empty input. Let's try that. Oh. Yeah, so missing method body. Oh. Oh. I'm getting ahead of myself. All right, we'll try that in a minute, but I don't think it'll let us do it without an argument. So yeah, if I try to compile this, it's going to complain that it doesn't know about this class scanner. Okay, so cannot find symbol. So if you look at the documentation for any of these classes and go up to the very top, it'll tell you where this comes from. In this case, scanner comes from Java utility scanner. So we've got to use something like an include statement, but it's an import statement.
Swedish chef's import.
Yeah. Pork. So scanner is defined inside util, which is defined inside Java, basically. So if we do that, it should compile fine. And if we run it, nothing happens. So now let's try our experiment. Without arguments. And I believe it'll compile, but it won't run. All right, so main method not found. Please define the main method as.
It's very specific.
It's very specific.
Please don't try anything different.
Yeah, exactly. Don't make me think. But it'll let us do bunny. All right, so S is a scanner object. And here's what we're going to do. We're going to use a pair of methods. We're going to say has next, which returns true if the scanner has another token in its input. And if it does, we can say scanner.next, and that'll return the next complete token from the scanner. So what's a token? When we did the word index and we were breaking things up between commas and parentheses and all that, we were tokenizing our input. We were saying, let's break this input into sets of pieces, right, which we call tokens. So typically, it's stuff separated by spaces. Okay, so think of a collection of characters with spaces on the beginning and end, or maybe the first thing in the input, and so on. And there's different ways that we can do this. We can say next big decimal, we can say next Boolean, we can say next line. Okay, there's all sorts of different options. Well, let's do the line. So let's say has next line, which tells us if there's another line of input, and then next line returns that line of input. So I can say something like this. Well, s.hasNextLine is true. And I'll call s.nextLine to read the next line, and I'll just print it out with some wordage around it. So I say this is fun, and it says the next line is this is fun. Ha ha ha. Goodbye. And I'll hit a Control D to mark the end of the file. Now if I had said something like this, and I redirect standard in from a file, my program is now printing out its own source code.
talked about.
That was the thing we talked about.
Yeah. How to do that.
This is the cheating version though, because it's not self-contained. We need the whole operating system there. But so next line is pulling in one line at a time, right? Now if we change this slightly to just has next, and we run, you can see how it's tokenizing, and it's just breaking things up with spaces or new lines. So we have a huge cache of ways that we can do input just using scanners.
Is the scanner the same way that like the compiler or interpreter or whatever interprets the code that we write? Like do they tokenize it down into each word and then check it?
Yeah, if you wanted to write a Java interpreter in Java, you'd probably make heavy use of scanners.
Where did you determine what it was reading, like your code?
Oh, I just redirected input. So I said run this and
right
redirect
there.
from
Okay.
main.java. Yeah. And remember, R is just Java main. So all these things available, right?
So if you didn't pipe it in, where it says S has next line parentheses, would you put in the file name into that parentheses?
Where are we?
Where the while statement,
Mm-hmm.
S has next, you put your file name in there.
So if you want to read from a file, we can construct a file descriptor. That was what was going to be next, but we're going to be out of time. But there's a class called file. And one way to construct a file object is just to pass the name of the file. So you can just pass a path name. And it'll return an object of type file, which we can use in the constructor of the scanner. So the scanner will let us construct by taking a file. Right here. But to make that work, we're going to have to get into a few other things, the most important of which is exception handling. Because if we just try to construct a scanner using file of a path name and we try to compile, it's not going to compile for us. It's going to say uncaught exception. And in general, when we do something in our code that could cause an error at runtime, the compiler is going to notice that and it's going to force us to handle that error. And it's going to be something that's called a try-catch block. And that's actually where we're going to start on Wednesday. So we'll talk about exceptions, and then we'll see how to process files. And then we'll go on from there, and we'll talk about PA2, and we'll talk more about Eclipse, and we'll have all kinds of good stuff to say. All right, so I will see you next time.